Okay, so we're saying rational functions are all functions that are in the form of P over Q, and the mother function is simply going to be 1 over x. They all come from this particular type of function. They all look like this. This is the mother function. This will give us the general idea of how all rational functions are supposed to look like. And from this, remember under functions, we're saying how do we get the domain of such an expression? Are you okay if I say all real numbers but not 0, right? We solve the denominator, isn't it? It's okay?
It is okay.
And we said the only way to get the range for this type of a function is to find its inverse. And when you get the inverse, you can find the domain of that inverse. And here the inverse happens to be the same thing again. When you try to get the inverse, it will be the same thing. So even the range is going to be all real numbers, but y should not be equal to 0 because the domain of the inverse is equal to the range of the original function. You're okay with this? You remember this part, right?
Yes, I'm okay with this.
So now, when we want to sketch these rational functions, the numbers that the functions cannot allow, for example, this guy here, the number on the x-axis that the function does not allow is called the vertical asymptote. Then the number that it cannot allow on the y-axis is called the horizontal asymptote. So this is the vertical asymptote, this is the horizontal asymptote. So I'll start by doing examples or rather questions from the 1120 tutorial sheet. These will be a lot and they will be enough before we look at the ones that you have from your 1100 tutorial sheet. So we start with the 1120 first. We're just doing question 7 from here. So like the first one, they're saying sketch the following. State their domain and the range, clearly indicating the intercepts and asymptotes. So there are going to be 3 cases that you should be expecting when you're dealing with rational functions. The first case, so before we even start this, let me just show you the cases you need to expect. The first case is when there is no x on the numerator, something that looks like this. Let's say 1 over x plus 2. If you have such a case like this, the domain is always going to be all numbers, but you solve the down part, meaning not -2. Then the range is fixed. Whenever you have case 1, where there is no x on top, the range is going to be all numbers, but y should not be equal to 0. It's always going to be like this. And these numbers that are not allowed are going to be a vertical asymptote. So the vertical asymptote is x is equal to -2. That's a number we're not able to cross. Then the horizontal asymptote is simply y is equal to 0. These numbers here, these guys here, the ones that are not allowed by the domain, those are the asymptotes. They are like limits that we can never touch. We can just approach them, but we cannot fully attach, we cannot really find them. Yeah, so are you okay with this part that I'm describing asymptotes, right?
Yes, I'm okay with this part.
So this is case 1. This is how we handle case 1 whenever there is no x on the numerator. This is the case 1. Then case 2 is when the numerator is at a lower degree as compared to the denominator. For example, if I give you this, then there's x squared minus 6x then plus, let's say, a 4 here. Or rather, let me just make life easy for us. Instead of making a big quadratic like this, I'll just say -25. The guy down has the biggest power is 2. The guy on top is a linear expression. That's what you have. So whenever this is called bottom dense, it's heavy at the bottom and it's light on top because the degree of the expression in the denominator is at a higher degree. It simply means that the domain is still going to be found in the same way. We solve the down part, meaning all real numbers are allowed, but x should never be plus or minus 5 because when you solve the down part, right, you just solve the down part all the time. X squared will be 25, then you square root. So we should take into consideration that x should not be both positive or -5 because the down part will become a 0. We don't want that to happen. Then the range is also fixed here. The range is similar to case 1, all real numbers, but not 0. And this will also help us to get the vertical asymptote. So here in this case, we're having 2 vertical asymptotes. The numbers we should never touch is -5 and x is equal to 5. These are the two vertical asymptotes, the numbers that were not allowed. Then the horizontal asymptote is simply y is equal to 0. This is the number that we should never touch. Any questions here, Nyumezi?
No, my biggest problem is like when you are plotting the money, how do you know what it's going to be?
Okay, let me just show the last case, then we start that. So case 3 is when they are of the same degree, when the numerator and the denominator, they are having the same degree of x. So let me say 2x minus 1, then you have, let's say, 6x plus 5, this guy here. So from here, you're okay with getting the domain. All real numbers, you know, but x should not be equal to, when you solve the down part, negative 5 over 6. This will happen to be a vertical asymptote, negative 5 over 6. Then, for you to get the range, you just say y is all real numbers. Get the coefficient of x from the numerator, divide it by the coefficient of x from the denominator. So it's going to be 2 over 6, which is the same as 1 over 3. Is this okay?
So you're saying that the range is coming from the numerator and denominator?
Yes, the range is going to be the coefficient of x in the numerator and the coefficient of x in the denominator. We are dividing 2 divided by 6.
Why do we do that?
It's just a shortcut. The other way we can get the range of this function is by finding its inverse, right? When you find its inverse, then get the domain, you get the same thing. It will be this. This is what you're going to get.
Okay.
So the easiest way is what we're doing here. You get the coefficient, which is, we say, should not be 2 over 6. Then we're just reducing it. This is what is becoming 1 over 3. This is for case 3. When they're of the same degree, even if there was a squared up, an upper part is squared, meaning they're of the same degree, you get the coefficients. The things in front of the biggest power is 2. Even if there's an x here and there's an x here, you get 2 and 6 is 2. Because they're of the same degree and the biggest degree is 2, so you get the coefficient of x squared, even here the coefficient of x squared.
Yes.
Okay, so if this is okay, we've looked at the 3 cases. The only thing that is changing is case 3, when you have that particular case when they are the same degree and the domain, the range changes to say we get the coefficients. So if you look at your question, maybe the easiest, let's start with yours as simpler. Your question 1 on question number 14, this is case 1, right? So you identify the case you're dealing with. That's a negative 4 over x minus 1. So let's call this as our first example. So we are having f of x is equal to, it's a negative 4 over x minus what? Minus 2, is it? So from here, what's the domain here, Nyumezi?
The domain is that x should never be positive 2.
Should never be 2. Then what's the range?
The range is all real numbers.
But
and
not...
y can be 0.
So this will give you a vertical asymptote. Your vertical asymptote is x is equal to 2. Your horizontal asymptote is y is equal to 0. Then from here you can get the x-intercept. So x-intercept is when y is equal to 0, does not exist. You are seeing that if you try to put 0 here, 0 is equal to negative 4 over x minus 2. You cannot solve this. It's not solvable, right? Because it's going to be 0 is equal to negative 4 when you're done. So meaning it does, which makes sense. The reason why it doesn't have an x-intercept is because the x-axis is the same as y is equal to 0. Because that's literally where y is equal to 0 passes. So we have the x and y. Y is equal to 0 is right here. And that's why we're supposed to draw the asymptote. So the asymptote, the y-asymptote, the horizontal one, is just the same line. Meaning we should never touch it. That's the x-axis. No wonder there's no x-intercept. Yeah, so it just makes so much sense that there is no x-intercept. Then y-intercept. Y-intercept is when x is equal to 0. Yeah, so we get x-intercept by expressing f of this to be equal to 0. We try to get x. It does not exist. That's a DNE that we're putting here. Then the y-intercept, when we put 0 wherever there's x, you get your y to be equal to what? Positive 2. So now we come to our function. This is your sketch. So we know the lines we should never cross. Y is equal to 0. That's a red thing that I've indicated here. Then the x-intercept, let me use a green one. The vertical asymptote, x is equal to 2. We should never touch 2. So meaning we should never touch this guy again. That's what you have. And because we're not allowed to touch 0 and 2, we are simply going to use the y-intercept to sketch this thing. So the y-intercept you got, we got a positive 2. Then we'll put our positive 2 here. We're supposed to touch this guy. And if we are going to pass on 2 without crossing the red line and the green line, it simply means it's going to be like this. This is going to be like that. Because we can never touch these asymptotes. But we can just go close to them as much as possible. That's what you're going to be learning later on in calculus, known as limits. Yeah. Then if you have this expression here, the twin will be in the opposite because the asymptotes are demarcating the x or y plane into 4 parts. There was this part, there was this part, and this part, and this part. Because the asymptotes, there is one here, and then there's one here. So the twin, the opposite, will simply be in the other section. So this is going to be your sketch for this graph.
Now how do you know if it's supposed to be like what in the other side, like on top, it's going to be down?
So you are saying, how do we know it's going to be on top or it's going to be down? Okay, so the y asymptote, we need to touch 2, and there's no other way that you can touch 2 apart from moving like this, because you are restricted with the asymptote. There's this line you should never cross at 2. There's also this line you should never cross. So how else can we touch 2? Because the mother function, the 1 over x, here the domain was what? All numbers but not 0. So the vertical asymptote here we got x is equal to 0. Even y, the horizontal asymptote was also y is equal to 0. If you notice, we should never touch this guy here, and we should not touch this guy here. So we have 4 sections. There are these quadrants that you have. How do you know which pieces we're going to have the mother function without having an x or y intercept? So we're going to be testing. By testing, I mean if you put a -1 in the expression, what number do you get? So if you put -1 in the expression, you get a negative, because 1 over -1 is negative. So meaning the graph is going to be down here, and the other twin will be the opposite quadrant, which is the other side. So Nyumezi, the y-intercept is determining which region we're going to sketch. Can I just restart this with the data that we have? So we have, you're okay with us having the vertical asymptote here, right? The 2, right? Then you're also okay with us having the horizontal asymptote, this line that we should never touch here, which is y is equal to 0, right? Then the x-intercept does not exist. The only thing that we have is the y-intercept, which is the 2 there. So we need to touch 2. So now the question we ask ourselves is, how can we touch 2 minus touching this red line and this black line that we have here? So the only way is by coming like this. Then we pass there, we touch 2, and we cannot cross by pass. So we can just move and get as close as possible to this line, but never touch it. Then the twin will be in the opposite section, which is this side. So the twin will just be there.
Okay.
Yeah, okay, let's do another one. You see, you just get familiar with this with time. Let me show you this other one here. This one is case 3, right?
Yes.
Yeah. They have the similar degree. So here, can you give me what's the vertical asymptote going to be? Let me just rewrite it, just a minute. Yeah, so example 2. There's f of x is equal to 6 minus 2x and 1 minus x. So here the vertical asymptote is x is equal to 1, right? The horizontal asymptote is equal to what?
The horizontal is, yes, it's 2.
Like this, you get the coefficients, isn't it? Hello, Nyumezi, you okay with how we got the horizontal asymptote?
Yes, I'm okay. So that we divide the coefficients.
The coefficients of x. The range will help us to get the horizontal asymptote. Then here, x-intercept x-intercept is when the function is 0. So when you put 0 on f of x, when f of x is equal to 0, the function will simply be x is equal to 3. That's the asymptote. Then the y-intercept is when x is 0. When you put 0 wherever there's x, you get y to be equal to 6. Are these okay?
Yes, that's okay.
So now if we're trying to sketch it, so let me show you this. So it just depends with what you have. So we are having the vertical asymptote is 1, the horizontal asymptote is 2. So meaning 2 is somewhere here. We should never touch 2. That's the horizontal asymptote. That's what we are saying. Then the vertical asymptote is at 1. We should never touch 1. No matter what happens, we should never touch this. We can never cross it, actually. That's what it means. Then the other part, we are saying we need to show the numbers that we are touching this guy. So there is what? There is
6 and 8.
We need to touch 3 and 6. So 3 on the x-axis and 6 on the y-axis. So how can we touch 6? The only way you can touch 6 is by moving like this. How can we touch 3? The only way to touch 3 is by moving like this.
Oh, that's how we know they are on different things. But they were getting confused. How are people getting how they're playing that?
Oh, yes. This is how we determine, yes. Yeah, so the intercepts really are the ones that we use to determine how the expression is going to be. So this is what we are having. Yeah. Then the same applies to, let's do the next one. The next one is the same thing. This guy here. So this is similar to that. Yeah, so this is just going to be, let's call this example 3. So you're having f of x, or rather y, is equal to 1 minus 4x. Then the down one is 1 minus x, so it's the same thing, 1 minus x. This is just going to be the vertical asymptote is x is equal to 1. The horizontal asymptote, you get the coefficients because this is case 3. Then you have what? That's a 4. Then the x-intercept. What's the x-intercept?
It will be 1 over 4.
1 over 4. Then the y-intercept.
Y-intercept will be 1.
The y-intercept will be 1, yes. So now if we decide to sketch it, this is just going to be, so we're having something like this. Okay, so it is going to be, there is the vertical asymptote, we have it, it's simply 1. Then the horizontal asymptote is 4. So we should never touch 4. No matter what, we should never bypass 4. And we should also never touch 1. There's a 1 here. We should never cross this line. Under calculus, we'll be crossing them, but for now we won't. So whenever you cross them, it's going to be an open thing, but here we don't. When you look at limits in calculus, we'll be able to, yeah, then here there's a 1 over 4 is before 1, so I'll put my 1 over 4 here. And then there's y is equal to 1. 1 is below 4, so there's a 1 here, right? So we need to touch this point and touch this point. So you notice that these points are in the same plane because we said the asymptotes are going to demarcate the x or y plane into 4 parts. There is this line here and this line here. So we have 4 parts, which is this part, and this part, and this part. So now you notice that the x and the y intercept are in the same part, in the same portion. So we're just going to connect them and touch them like this. This is what you're going to get. Then the twin is going to be in this thing there. So this is what you're going to get. This will be your graph. You even tell them the domain and the range. This is basically what you have. Is this okay?
Okay. Yes, it is okay.
You're sure it's making sense now?
Yes, now it's making sense.
Okay. Okay, so it's the same thing even as compared to the last one here. The same way that you do the same way that we did the first one is how we do this guy. We know to say whenever it's case 1 like this, the vertical asymptote is going to, x is equal to 2. The horizontal asymptote here is what?
Y is equal to 0.
So yeah, it's y is equal to 0. Yeah, and then the x-intercept. Do we have an x-intercept in this case?
No.
No, it does not exist. You put D and E. That's a mark for this. Then y-intercept. y-intercept, when you put wherever there's x to be 0 is what? Y is equal to negative 3 over 2, right? So now if we decide to sketch it, just demarcate your x or y plane into 4 parts. So we have a 2 that we should not touch. So this is what there's a 2 and a 0. So 2 on the x. So we're just saying there's a 2 that we should never touch here. That's what you have. Then there's this y is equal to 0 that we should never touch here. This line here, we should never touch it. No wonder we don't have an x-intercept. And the y-intercept is what? The y-intercept, you said negative 3 over 2. Negative 3 over 2 is somewhere down here. Negative 3 over 2 on the y-axis. So we'll just come like this, touch this guy and go down. Then the twin will be in the other portion, which is that. Yeah.
No, I understood.
You're sure now it's okay? How about this complicated one? So this is similar to case 1, case 1, case 1. We've done this. These are okay, right? Case 1, we've done something like this. ABC, right?
Yes.
Now what about when we have a quadratic like this one here? So this one, these are all the same. What I will do here is what you do in all the cases, because these are all case 2s. Case 2, we said it's when the numerator is at a lower degree than the denominator. That's what we have, and these are all case 2. So I'll just solve this one here, E. It will be a template for you to solve anything that looks like that. So you have what? You have x plus 3 on top. Okay, so let's create this to be example 4. X plus 3. Then down you just have x5 negative x squared plus 4x then minus 5. So the domain and the range are okay with this. I'll just go straight ahead to the vertical asymptote. So the vertical asymptote here is going to be what? You solve the down part. When you solve this quadratic, do it there on a piece of paper. What 2 answers of x are you going to get?
Would it be negative 1 and 4?
Negative 1 and 4?
The factors. Yeah, the factors. Then x, this one here. I'm coming. I'm just confused. What when you multiply it gives you negative 5, when you add it gives you 4.
So the product is negative 5, the sum is 4. Then the factors, we're simply going to use a 5 and negative 1.
Oh, so I made a mistake in saying negative 4.
Yeah, so that when you put them here, we're just going to say x squared, then minus x, then plus 5x, then minus 5. This is going to be x minus 1, then plus 5 and x minus 1. So we're simply saying there's a 1 and there's x is equal to negative 5. When you solve the down part, so this is what you get. Those are going to be your vertical asymptote.
Yeah.
So now the vertical or the horizontal asymptote for this one, we said it's fixed as well. Y is equal to 0. That's what we have. So now the x-intercept, if you try to get the x-intercept, what's the x-intercept going to be here?
It will be 1 over 3.
It will be what?
1 over 3.
X-intercept.
Yeah,
Yeah, it will it will be, when you put a 0 here in your maze and cross multiply, it's just going to be -3 when you solve the thing, right? Okay, y is equal to, we're putting a 0 this side, and then we have x plus 3, then down we have x squared plus 4x, then minus 5. Cross multiply here, what do you get? It's 0 is equal to x plus 3, right? Yeah, so we get this. This is our x-intercept. Then y-intercept, we put wherever there's x, we put a 0. So if you put a 0 there, a 0, a 0, you'll just get y is equal to -3/5, right? Yeah, sure, it's okay?
Yes, that's it. I mean, I do math school.
Oh, okay. Then from here, we're trying to sketch this. So, okay, if this is okay, now if we try to sketch it, yeah, we'll simply have, we have two vertical asymptotes. Yeah, so the two vertical asymptotes that we have, we said we have, so for the vertical asymptote, we got 1 and -5. So we have 1 and -5. So we have a 1. So a 1, we're simply going to have a 1 here. So this is a 1. Yeah, so we can have this guy here. And we have a -5, which is a -5. So meaning we are not allowed to touch these two numbers. Yeah, we should never cross them. Then the horizontal asymptote is y is equal to 0. So meaning we should also not touch this line here. Let me put it in black. This guy here, we should not touch it. This guy here should not be touched. Then, okay, let me see this. Horizontal asymptote, is that okay? Then the x-intercept is -3. So where should we touch -3? Okay, this I think is -3. So -3 is somewhere here. We've gotten an intercept on a line that we should not touch. So this is what we are having there. So I'll show you what we do. Then the next thing is the y-intercept. The y-intercept is -3 over 5. So -3/5 is somewhere here. Here it's allowed. We can touch this guy. Then how do we connect these two guys here? When we're not allowed to touch, because these are, it's going to be, okay, let me just sketch the answer, then I'll explain it. So here we need to touch this guy, but we have to leave it open to show that we are skipping it. It's open at this point. Then we continue like this, then come like this. Let me just try to make it more representable. So it has to come nicely. Okay, so it has to come nicely like this, come like that, then bypass here and then come like that. Then the twin, how do I know? Because we have these other portions that we have not accounted for. So if you want to find out where the other pieces are going to be, you have to be checking. You test. So by testing, you choose any value which is above, like this guy here. This was a 1. So you choose any value which is above 1. For example, I can use a 2. If I put a 2 in our expression here, 2 in the whole thing, the top guy here is going to be a 5. The down part, this is going to be a 4, 8, that's a 12. This is 4, that's a 12. 12 minus this. The answer is positive regardless. That's 12 minus 5. Yeah, which is what, a 7. So the answer is positive, meaning it's above here. This side it's above, because the only time you put a positive thing and get a positive is when x is positive and y is positive. So meaning the piece here will be above. If you put something negative, let's say -6, the answer will be in the negative. You get a negative. When you put a negative, you want a negative, meaning it's down. So this is how your function is going to look like. Whenever you have two vertical asymptote, it will be demarcated into 6. And if you ever have to touch or cross an asymptote, you always make sure it's open at that particular point. That's how you show like an open thing to say we need to skip at that particular point because the limit does not exist.
Okay.
Yes. Yeah, so that's how we basically do this type.
Actually, can you give me some questions on this so that I can try them out on your phone?
Okay, so you can just take a screenshot of these guys here. You can just attempt and show me what you get on these ones here that I'll highlight. So we can just do this and that and that and this. At least the more you do them, the more you get familiar with the whole process.
Okay.
Yeah. Is this okay?
Yes, it is okay.
Yeah, so this is on rational functions. This is basically what you have.